Hello, everyone. Welcome to this lightning talk, Shaping the Future of Cloud-Native Infrastructure in the Age of AI, 5G, and Edge. My name is Xiong. I'm with Futurewei Technologies. Today, in this talk, I'm really excited to introduce you a new open source project that is designed for next generation applications. So let's go ahead and get started. First, let's look at some of the challenges that we are facing today. As the cloud adoption grows exponentially, the infrastructure platform needs to manage larger and a larger scale of compute and network resources across geographic area. The customer always asks for faster and faster provisioning of their resources or their applications. Additionally, there is an increasing need for cloud operators to unify the management of diverse type of resources, such as bare metals, VMs, containers, and serverless functions, to just simply reduce the management cost and simplify our operations. With the emergence of the new type of workloads, such as AI, 5G, and IoT apps, we see a trend that traditional cloud computing and edge computing are being converged into one distributed cloud. This trend requires that the current infrastructure technologies need to be redesigned or optimized to support applications running at resource-constrained edge nodes that are closer to the customer and the customer data. As a result, for those new type of workloads, we need the cloud infrastructure to be able to intelligently place where the application should run in order to improve customer experience with low latency and high throughput. Last but not least, the trend in the area of cloud native continues. Due to its extremely scalable and extensible design, we believe the modern cloud infrastructure should incorporate this cloud native design pattern into the platform to meet the challenges faced by new generation of applications. So now I'm pleased to announce and introduce you the new open source project called Centeras. The goal of Project Centeras is to provide a new infrastructure platform in a more cloud native way for any company to build scalable and unified infrastructure for the public or private cloud. Centeras platform is designed from its beginning with hyperscale, edge computing, and fast compute network provisioning in mind. Centeras projects actually consist of two sub-projects. We named them Arctos and Mesa. More detail on Arctos and Mesa will be discussed in the following slides. This is our architecture of Project Centeras. I won't be able to deep dive into this architecture in detail, but I would like to mention a few highlights. First, regional scalability. One of the visions for the Project Centeras is able to support a cluster of 300,000 computing nodes and be able to provision and manage more than 10 million network endpoints within a region. So every component in this architecture can be partitioned to handle a large number of requests. Second, this architecture natively supports edge computing. It's built in to schedule, run, and manage applications at edge size. Lastly, this architecture also offers the same API experience for both VM and the containers, as well as for other types of workloads. It provides application-centric API is a platform for both resource and application orchestrations. Centeras Arctos components is derived from well-known Kubernetes architecture. However, we made some major redesigns and extensions to the core of Kubernetes. Here is a list of the changes that were made. Partitioning and scalability. In Arctos, API server, etcd store, controllers, schedulers, all can be partitioned for large-scale deployment. Multi-tenancy. Arctos introduced the true and hard multi-tenancy into the Kubernetes and make the platform a real multi-tenant platform. Unify the runtime. Octos unify VM and the container runtime into one, so that the platform manages VM in the same way as it manages containers. Octos introduce new network object types and the corresponding operators. This is a part of a multi-tenancy model, so that containers or VMs are created within subnet or VPC, and they are naturally isolated. Built-in edge computing. Octos out of the box can manage computing nodes at the edge size and orchestrate applications running at a resource-constrained edge. Similarly, Centera's Mesa component is a network component that provisions and manages the virtual network and processes network traffic. Mesa itself has two components, data plan and the management plan. The data plan is built on top of high-performance XDP/eBPF programs. XDP programs running within the OS kernel to perform routing, switching, and a load balance of network traffic. Mesa using natural partitioning of a cloud network such as VPC and subnet to scale network endpoint provisioning for attending VMs or containers, as well as for fast networking forwarding. Mesa management plan runs within a Kubernetes and using Kubernetes CRD and operator framework to manage virtual networks and network package routing policies. That's all for me for this short talk. Thank you very much for your listening. Please visit our virtual booth for more detail about projects and Terras. Thank you very much. Bye.